This is sections 8.8 and 8.9 of Honors Algebra 2, linear interpolation. Oh, that sounds like fun. We'll get to linear interpolation in a few minutes. First, something different. The rational root theorem that we had in the last video and that we used in class the other day is incredibly useful in finding rational roots. In fact, it gives us a finite number of possible rational roots. And if we're going to have rational roots, they have to appear in that list. It does absolutely nothing for us in finding irrational roots. So finding rational roots, awesome. Finding irrational roots, lame. It does nothing for irrational roots. So what if our polynomial has no rational roots and all we have are irrational roots? How in the world do I solve it? Graph it. Remember, real roots, whether they are rational or irrational, roots that are real numbers are simply the x-intercepts of the graphs. If the roots are complex numbers, they're not going to be x-intercepts of the graphs because we can't graph complex numbers in the xy coordinate plane. But the real number roots will be x-intercepts of the graphs. So if I can graph it, I can find the x-intercepts, or at least approximate them, estimate them. So how do I graph it? On my calculator. For example, estimate the roots of x cubed minus 2x squared minus 4x plus 2 equals 0. I'll give you a minute or a few seconds to grab your graphing calculator and get it out, and you can do it with me. Oh wow, that was fast. It's almost as if you have the ability to pause time or something. Okay, here we go. Here's my graphing calculator. You've got yours. You can do it as I do it. So we're going to graph this on our calculator. So we're going to go to y equals. We're going to enter in our entire equation minus the equal 0 part, just the left-hand side. So x, which is the button right below mode, cubed, and I can just use the caret key, that little arrow thing above the division sign, and I can put in a 3. Use the arrow button to move out of the exponent. Do minus 2x, and there's a x squared button on the left-hand side of my calculator, minus 4x plus 2. X cubed minus 2x squared minus 4x plus 2. I put it in my calculator under y1. Okay? I'm going to go to zoom, which is the middle button here. I'm going to choose number 6, zoom standard. So I can scroll down to number 6, so I can just type the number 6, hit enter. That sets my window to be negative 10 to 10 on the x-axis and negative 10 to 10 on the y-axis. And that is enough generally to see all of my roots. I know this is a cubic equation. I know it should have 3 roots. I see 3 places where it crosses the x-intercept. Where it crosses the x-axis, I mean 3 x-intercepts. That means all 3 of my roots happen to be real numbers, so I can find them. My calculator can do that for me. To do that, I click second, calculate, which is the trace button. And then I go down to number 2. I want to find a 0. Remember, x-intercepts of my graph are the zeros of my functions. So I want to find a 0. So I click enter. Now there are 3 different ones. So my calculator wants to know which one I want to find. So it asks me 3 questions. First it asks me the left bound. So I have to use the arrow buttons on my calculator, and I have to move to the left of the 0 I want to find. So let's say I want to find the furthest left one. So I move someplace to the left of it. See how my cursor is now on the graph to the left of the x-intercept I want? Good. Then I click enter. And it asks me for a right bound, so I need to move to the right of it. This is telling my calculator where to look. So it's going to look between the left and the right bounds. And then it asks for a guess. So I can just leave it where it is and click enter again. And now it tells me what my 0 is. Now is it exactly negative 1.514137? No, the decimal keeps going forever. It's an irrational number, so the decimal doesn't end. But my calculator has truncated it. It's cut it off there at 6 decimal places. So my answer is, or one of my roots, the roots are approximately Let's use a squiggle equal sign. And that was negative 1.514. Okay, let me find another one. There are 3 of them, so I'll do the same process. Second, calculate number 2, which is 0. I move to the left of what I want to find. Any place there is good. I move to the right. Click enter. Guess. Right where I am is a good guess. And it tells me 0.428. So let me write that one down. 0.428, comma. Let me go back and find the third one. Second, calculate. Number 2, left bound. That looks good. Enter. Right bound. That looks good. Enter. Guess. Enter. And it tells me 3.086. 3.086. Now again, are these exact? Absolutely not. But they're approximations. So that's better than nothing. And since the rational root theorem doesn't apply to this equation, I don't have a way to solve it on its own, except to just guess some random irrational number and see if it works. Not a very good approach. So graphing it gives me a good guess. And in the real world, that's all I really need. Another example, x to the 4th minus x cubed plus x squared minus 3x plus 1 equals 0. We will graph it. I will go to y equals. I'll clear out the graph I have there by clicking the clear button. Or the equation, I'll clear that out by clicking the clear button. I'll do x to the 4th, so x, caret key 4, use the arrows to get out of my exponent, minus x, caret key 3, use the arrow key to get out of my exponent, plus x squared minus 3x plus 1, zoom 6. It graphs it. Hey, this one only crosses the x-axis twice. If I want to see a better view of it, I can go to zoom, and number 2 is zoom in. I'll click enter. If you notice, there's a little dot at the very center that's flashing. So I'm telling it where I want it to zoom in at, so I can just click enter there, and it will zoom in for me. Give me a better view of these things. There they are. So I can now clearly see it only crosses twice. But it was a 4th degree equation. That means 2 of the solutions, 2 of the roots, are complex, so they don't show up on my graph. Okay, so I can find these 2. I go to second, calculate, number 2, left bound, right bound, guess, 0.368. So approximately 0.368, comma, back to my calculator. Second, calculate, 0, left bound, right bound. There we go. And guess, enter, 1.43, 1.428. And I'm done. Cool. Graph and estimate the real roots to 2 decimal places. So on your calculator, be careful. In order to do a negative, you're not using the minus sign. You're using the button next to the decimal point. That is a negative. Do not press minus x to the 4th, because then it's trying to subtract and it doesn't have anything to subtract from. So use the negative button, which is the button to the right of the decimal point.